Machining processes. Machining process. The process in which chip is removed from the workpiece, metal, is called machining process. The machines used for machining process are lathe, drilling, saper, slaughter, planer and milling machines. This section gives brief description of the construction and working principles of the machines, the operations and advantages of each type of machine. 1 lathe. Figure 1 lathe machine. Construction and working of lathe. 1. It has a heavy bed which is supported on 2 legs. The bed has guideways in which the carriage and tailstock will move. 2. The headstock has gearing arrangements for clockwise and anti-clockwise rotation of the spindle. Also, there is provision for slow rotation during thread cutting operation. 3. The carriage is moved along the guideways by means of hand traversing wheel. A cross slide which slides across the guideways by means of another wheel as shown in figure. 4. A compound rest is fixed on the carriage which carries a tool post in which the cutting tool is fixed in position. The compound rest is used to give fine cutting during the turning operation. 5. The compound rest can rotate about its vertical axis to facilitate taper turning operation. 6. There is a tailstock which carries a mandrel to accommodate dead center or drill boring tool which can be moved by means of a hand wheel. The tailstock moves along the guideways to provide support for long objects, products. 7. The headstock spindle is fixed with either 3-jaw chuck, self-centering, or 4-jaw independent chuck to hold the workpiece. 8. For thread cutting, the carriage is locked to the lead screw and moves towards the headstock. Various operations that can be performed on lathe. Figure 2. Operations on lathe machine. A. Facing operation. It is the operation in which the metal is removed on the front surface of the workpiece. B. Plane turning operation. It is the process of removing metal along the cylindrical surface of the workpiece. C. Forming operation. The process of removing metal to get concave form on the cylindrical surface is called forming. D. Grooving operation. The process of cutting grooves is called grooving operation. E. Knurling operation. It is the process of making hard impressions on the cylindrical surface for gripping purpose. F. Drilling operation. In this process holes are drilled axially in the workpiece. G. Reaming operation. It is an operation of enlarging the drilled hole throughout. H. Boring operation. It is an operation to slightly enlarge diameter of a part of the drilled hole in the workpiece. I. Counter boring operation. It is the operation by which a part of drilled hole is more enlarged in diameter. J. Chamfering operation. It is the process of making blunt edges, slightly inclined, at the front part of the workpiece to avoid sharp edges. K. Taper turning. It is the process of reducing diameter of the workpiece gradually from one end to the other end. L. Threading. It is the process of cutting threads on the cylindrical surface, right-handed or left-handed threads. Advantages of lathe machine. 1. It is a versatile machine which can be used to carry out different operations on workpieces of different sizes. 2. The operational processes are easy and simple compared to other machines. 3. The cost of making the product processing cost per unit of the product is minimum. 4. It is available in different sizes, hence suitable lathe for our purpose can be purchased. Initial cost is moderate. 2. Saper. Figure 3. Saper machine. Construction and working of saper. 1. It consists of a solid base which supports the column and table. The column is housing for the mechanism to convert rotatory motion to translatory motion. 2. The table is a hardened steel block which contains slots on its top to accommodate vices to fix the workpiece. The table can be moved up and down on the elevating screw by a lever. 3. The ram at the top of column slides in guideways to and fro. The stroke length can be adjusted by means of a hand wheel as shown in figure. 4. The front portion of ram has a swivel head to facilitate tool slide to be fixed at the desired angle to work on angular surfaces. 5. The tool slide can move up and down in the guideways provided in the swivel head. There is a hand wheel to impart feed after every stroke. 6. The cutting tool is fixed to the tool post which is attached to the clapper box. The purpose of clapper box is to free the cutting tool during return stroke to protect its cutting edge. Operations performed on saper machine. A. Machining horizontal surfaces. B. Machining vertical surfaces. C. Machining inclined surfaces including dovetail. D. Machining irregular surfaces. E. Cutting slots and keyways in shafts. Figure 4. Horizontal, vertical, inclined, keyway cutting. 3. Planer. Planer is another important machine used in industry for large-sized objects to remove more metal and to carry out simultaneous cutting operations on different sides. Very long objects, blocks, with multiple cutting operations like slotting, grooving and plane, vertical or inclined surface cutting operations can be carried out simultaneously. Construction and working of planer. 1. It consists of a heavy bed which is twice long as the table. The body has V-grooves on its top surface in which the table will slide. 2. A table which is a heavy block with T-slots on its surface and V-projections on its bottom surface will move to and fro in guideways of block. The workpiece is fixed or laid on the table in position. 3. The 2 vertical columns are connected by means of cross beam. The columns provide support for the cross rail which carries a tool head, vertical tool head. 4. The cross rail can mount tool head, S, and move up and down on the columns. The tool heads can be moved horizontally by means of feed screw. 5. The vertical columns accommodate tool heads, side tool heads, one on each column for machining on vertical, side, surfaces. By providing down feed, vertical tool head, and cross feed, horizontal tool heads or side tool heads, the machining operations on different surfaces can be carried out simultaneously. Planer operations. A. Planning horizontal surfaces. B. Planning vertical surfaces. C. Planning inclined surfaces including dovetail. D. Planning T-slots and grooves. E. Planning curved surfaces. Figure 5. Planer and operations on planer. Differences between saper and planer. No. Saper. Planer. 1. Workpiece is stationary while tool reciprocates. Tool is stationary and workpiece reciprocates. 2. It is a light-duty machine. It is heavy-duty machine. 3. Meant for small workpieces. Meant for heavy, large and long workpieces. 4. Setting of workpiece is easy. Setting of workpiece is difficult. 5. Only light cuts applied. Heavy cuts can be applied. 6. Tools are smaller in size. Tools are bigger in size. 7. Only one cutting tool is used at a time. More number of cutting tools can be used. 8. Only single piece can be machined at a time. More number of identical work pieces can be machined at a time. 9. Less accurate machining. More accurate machining. 10. 15 to 20 HP motor is used. 150 HP motor is required. For milling machine. So far, we have come across machines like lathe, saper, planer where the cutting tool which is static and has a single point cutting edge. But the milling machine uses a multi-point cutter to remove material as the cutter rotates. The cutting edges come in contact with workpiece successively to remove the material. The milling machine may be I. Horizontal, 2. Vertical or 3. Universal miller. Figure 6. Horizontal or plane milling machine. Construction and working of horizontal or vertical mill. The basic construction of both horizontal and vertical milling machines is almost similar. They vary only in the position, horizontal or vertical, of the spindle which carries the cutter. 1. It consists of a heavy base on which the column and elevating screw are mounted. 2. Column is the main supporting frame which has guideways for the knee to move up and down. The top of the column holds an overarm and a spindle. 3. The spindle arbor has spacers which are of different lengths that help in proper positioning of the cutter. The cutter rotates while the workpiece is moved across it. 4. There is a table which is fixed to the saddle having dovetail groove as shown in the figure. The workpiece is mounted on the table. 5. Saddle can move in guideways on the knee while the table can traverse in a perpendicular direction to the guideways to feed the workpiece. Milling cutters. Milling machine uses different cutters, namely A. Plane milling cutter, B. Side milling cutter, C. Face milling cutter, D. Slitting saw cutter, E. Angle milling cutter, F. End milling cutter, G. T-slot cutter, H. Form milling cutter, convex, concave or involute. The cutters are as shown in the following figure. Figure 7. Milling machine cutters. Milling operations. 1. Plane milling, the operation of producing plane, flat and horizontal surfaces parallel to the axis of rotation of the milling cutter. 2. Face milling, the operation of milling flat surface on the face of the workpiece while the axis of the cutter is perpendicular to the workpiece surface. 3. Side milling, the operation of producing flat vertical surface of the workpiece. 4. Straddle milling, the operation of producing flat vertical surface on both of the workpiece simultaneously using 2 side milling cutters. 5. End milling, it is the process of producing slots, grooves and keyways in the workpiece. It is done on vertical milling machine. 6. Angular milling, it is the process of cutting angular surfaces on the workpiece, V-slots. 7. Gang milling, it is an operation of using multiple cutters to make combination of operations, on horizontal and vertical surfaces of the workpiece. 8. Saw milling, it is the process of making narrow slots or grooves on the workpiece. 9. T-slot milling, it is the process of cutting T-slot on the top surface of the workpiece using vertical milling machine. 10. Dovetail milling, it is the process of making dovetail slot in the workpiece using a vertical milling machine. Figure 8. Different milling operations. Types of milling operations. 1. Up milling, in this process the cutter rotates against the direction of travel of the workpiece. Cutting edges move upwards. Chip removal increases from minimum at the beginning and reaches to maximum at the end of the cut. 2. Down milling, in this process cutter rotates in the same direction as that of the workpiece. Cutting edges move downwards. Chip removal is maximum in the beginning and decreases to minimum at the end of the cut.